Hello students, how are you? Welcome to all of you in the fifth semester course on Process Instrumentation and Control of 3-year Diploma in Plastic Technology under Punjab State Board of Technical Education and Industrial Training Chandigarh. So myself Pankaj Chawla, lecturer Chemical Engineering at Pandit Jagat Ram Government Polytechnic College, Hoshiarpur. So I am going to teach you in this particular semester the subject on process instrumentation and control. Before we start, here is a disclaimer announcement. The material presented hereby through series of video lectures on process instrumentation and control does not claim any originality and cannot be used as a substitute for prescribed textbooks. The matter presented here is prepared by the author for completing his teaching assignments related to the syllabus prescribed by Punjab State Board of Technical Education and Industrial Training Chandigarh for the fifth semester subject on process instrumentation and control of 3-year diploma course in plastic technology by referring the textbooks, reference books, e-books and the material available on internet. Further, the e-content presented through series of video lectures is not intended to be used for commercial purpose and the author is not accountable for any issues, legal or otherwise, arising out of use of this e-content. So today we are going to start with the very first chapter on process instrumentation and control, that is introduction. So before we start the introduction, let me explain what this subject is all about. So this subject consists of two parts. First one is the process instrumentation and second one is the control. In the first part, process instrumentation, we will study the different types of instruments which are involved in measurement of important process variables like temperature, pressure, level, flow, and some chemical composition analyzers we will also study in, and the second part is related to the control. So the first thing is you have to measure a physical quantity or a physical variable, then you have to control it. So how you can control it, that we will study in detail in the second part. So today we will start with the first chapter, that is on the introduction. So today we will cover the following broad topics, that is under the introduction, that is preamble, measurement, meaning and purpose of measurement, types of measurement, instrument and instrumentation, importance of instrumentation. So first of all, we will start with the preamble. So as you all know, a wide number of physical quantities, variables such as temperature, pressure, volume, flow, etc. have to be measured or sensed simultaneously during a process. So these are required for a number of reasons, but the important one are, first one is the optimizing the process conditions so that you are having a higher yield. In order to increase the yield of any product, you have to optimize the various process variables. So for optimizing that process variables, you need its measurement first, then you have to apply some control strategy. Next is producing a quality products. So this is again a very important aspect. So if you are producing a quality product, then selling is not a problem and you can survive in the market for a for the long term and you can fetch the larger amount of profit. Next is for improving the productivity, that is for the given input you have to maximize the output. So that you can do with the help of measurement, with the help of various instruments and the various control strategies. Next is for minimizing the cost. So that is last but not the least very important. So if you are producing a quality product at a minimum cost, then you can say the selling capabilities are definitely higher, or your you can say the product life cycle is also longer. Next is in the physical sciences or the process engineering and the product quality assurance, measurement is the activity of obtaining and comparing the physical quantities. So you have to measure any physical quantity by comparing it with some other physical quantity. So there are established standards that are known as units, and the process of measurement gives a number relating the item under study and the reference unit of measurement. So there are two aspects that you should understand whenever you measure anything. There are two things: one is the numerical value and other is the unit. So these two have to be carefully chosen. If you have chosen a larger unit, then the numerical value associated with a particular physical quantity is smaller. If you have chosen a smaller unit, then the numerical value associated with the physical quantity is larger. So this is about the preamble. Next we will start with the measurement. So measurement is the process of associating numbers with the physical quantities and the phenomena. Measurement is fundamental to the sciences and to engineering, construction and other technical fields, and to almost all everyday activities. Frequently we require the measurement. For this reason, the elements, conditions, limitations and the theoretical foundations of measurement are much studied. So measurement may be made by unaided human senses, in which case they are often called estimates. So we always have a guess for any, you can say, physical quantity, so with the help of our human senses. So for more commonly by use of instruments, they may have varying complexities, so we can accurately measure the various physical quantities. So for example, the simple rules for measuring length, or highly sophisticated systems designed to detect and measure the quantities entirely beyond the capabilities of the human senses, so that you cannot, you can say, think of to measure with the help of your senses. For that you need some instruments or some sophisticated instruments. So for example, the radio waves from the distant star, for this purpose you require a specific instrument. Next, magnetic moment of a subatomic particle. Again, you require a very sophisticated instrument for this. You can't determine the magnetic moment of a subatomic particle with the help of your senses. So human senses fail to measure this magnetic moment of a subatomic particle. So here you need some sophisticated instrument. So measurement begins with a definition of a quantity that is to be measured. It always involves a comparison with some known quantity of same kind. So measurement is frequently made by comparing it with some standard, right? Like for weight, some you have to compare it. So for example, you are buying a vegetable from the market. So what that ready wala and the people who is selling that vegetable is doing is comparing the vegetable with some standard weight, right? And give you that vegetable measuring 1 kg. Next is, if the object or a quantity to be measured is not accessible for direct comparison, it is converted or transduced into an analogous measurement or signal. So if it is not accessible, or you can, for direct comparison, what we are doing, we are converting it into some other variable or other signal, or with the help of some transducer, right? So that signal is again the calibrated in terms of the physical quantity which is to be measured. So that part we will cover in the subsequent lectures in detail, the calibration and how that measurement is made. Next is the measurement always involves some interaction between the object and the observer for observing instrument, right? Some sort of interaction is always there. So there is always the exchange of energy, which is in most of the everyday applications is negligible. So whenever there is exchange of energy, it definitely going to alter the value of the variable. If it is negligible, then it is not a problem, right? But on the other hand, if it is considerable, which is the case for some types of measurement, then it limits the accuracy of that instrument. So adequate, you can say, the compensations has to be made while calibration for such type of instruments. Measurement generally makes use of an instrument as a physical means for determining the quantity of variable. So it generally makes use of, the instrument generally makes use of some physical means for determining the value of some physical quantity or variable. So instrument serves as an extension of manual capabilities. Here this point is important. So it is going to extend the manual capabilities, like we have just discussed. So you cannot determine the magnetic moment of a subatomic particle. So it is beyond the manual capability, but with the help of an instrument, you will definitely do that. Enables a person to determine the value of an unknown quantity which unaided person cannot measure. So this is about the measurement. Next we will discuss the meaning and purpose of measurement. So these are the two important things when we measure anything. So you should understand first of all the fundamental and underlying purpose of measurement in the industrial manufacturing or processing. Why we are measuring this? What is the purpose, right? So that must be known to you. So to aid in the economics of the industrial operations by improving either the quality of the product or efficiency of the production. So for, you can say, having a competitive edge or for improving the economics, these are the two important things. You should improve either the quality of the product or improve the efficiency of the production. Both these require some sort of measurement, whether you are going to produce a quality product or whether you want to increase the efficiency of production. You need to measure something, some variable or important variables, or you can say the key variables. You have to measure it. In view of this purpose, one should always bear in mind these are the questions in regard to the measurements. So these are the some of the questions which needs to be answered. Number one, why is the measurement being made? Next is, what should the measurement mean, right? Next is, what measurement is made? You have, next is, what is the result of making this measurement, right? These are the some of the important, you can say, questions that needs to be answered before making an measurement. So in industrial operations, it is very difficult to answer all these, you can say, questions, but you are not going to get the answer to all these questions. So for the measurement, these are the two important, you can say, points or two important questions that needs to be answered. What is the purpose of measurement and what is the meaning of measurement? Means how you are making that measurement to serve your purpose, right? These are the two key aspects that should be known to you beforehand. What is the purpose of measurement and what is the, you can say, the purpose of processing operation, and what is the meaning of measurement, what you are measuring in order to fulfill your purpose. So this accomplishes a specific result is one should wants to do, or one should wants to achieve. So this is about the meaning and measurement. Now we are going to discuss the types of measurement. So types of measurement is broadly classified into two types. Number one is the direct measurement and another one is the indirect measurement. So first of all, we will discuss the direct measurement. A measurement is said to be direct measurement if the meaning of measurement and the purpose of processing operation is same. So we have just discussed that there are two important aspects, that is meaning of measurement and the purpose of processing operation. If these two are same, then the measurement is said to be direct measurement. So direct measurement is tremendously important approach in the modern instrumentation. So this direct measurement is widely used. For example, in manufacturing a mechanical part in a lathe section of a machine shop. So what is the purpose of processing? The purpose of processing is to produce a part with given physical dimensions. Suppose you want to make a cylinder. So the length of the cylinder and the diameter of the cylinder is the important parameters that needs to be, you can say, closely matched with the specifications of the product or with the, you can say, the part which as per the part design or as per the dimensions. So what you are doing during and after the operation or measurement of its dimensions called specifications are usually made. So every time you are, you can say, measuring the diameter with the help of some instrument like vernier caliper or the length of that cylinder physically after each step of the processing. So this is called a direct measurement. So why it is called a direct measurement? Let's go into that. Meaning of measurement is determining a physical dimension. So what is the meaning of measurement? So we are determining a physical dimension with the help of a vernier caliper. If you want to produce a cylinder of given dimensions, then what is the purpose of processing operation? That is producing a physical dimension or having a cylinder of specific length and specific diameter. So here two are matching. The meaning of measurement and the purpose of processing operation are identical, right? So hence it is a direct measurement. Next is the indirect measurement. A measurement is said to be indirect measurement if the meaning of measurement and the purpose of processing operation is different, right? If these two are different, then the measurement is called indirect measurement. Now let's discuss it with the help of an example. Suppose the measurement of temperature in a milk pasteurizer. So what is the purpose of a milk pasteurization? Is to do the pasteurization of milk. And what is pasteurization? Pasteurization is a process in which we are eliminating or killing the certain type of bacteria that are known as pathogenic bacteria or disease producing bacteria. So what is the purpose of pasteurizing operation? The purpose of pasteurizing operation or pasteurization is to eliminate bacteria. Now what is the meaning of measurement? Meaning of measurement is the measurement of temperature of milk. So we are measuring the temperature of the milk. So this is an indirect measurement. So what we are what is our purpose? Our purpose is to eliminate the bacteria, but what we are doing, we are measuring the temperature of the milk. So what is the theoretical background behind it is, so whenever we keep the milk at a specified temperature, or you can say a high temperature, for a short period of time, what will happen? The number of you can say the bacteria, especially the pathogenic or disease producing bacteria are killed, right? So that is the purpose. Now in this example, the meaning of measurement is determining the temperature of pasteurizer. Means in the pasteurizer there is a milk. We are determining the temperature of milk, and the purpose of processing operation is eliminating bacteria. Now here these two are different. The meaning of measurement is the temperature, and the purpose of processing operation is eliminating bacteria. So these two are not identical at all. So hence it is an indirect measurement. Now what would be the case, how you can change this from indirect measurement to direct in the last example? So a direct measurement in this example would be the determining the bacteria count. So instead of measuring the temperature of the milk in a pasteurizer, if you are by some means counting the bacteria, means your aim is to reduce the bacteria count, right? So if you are synchronizing it synchronizing your measurement by determining the bacteria count with your purpose is to eliminate the bacteria, then these two are same. In that case it will be a which type of measurement? Direct measurement. So the point of these examples is to bring out the meaning and the intent, means the purpose of measurement same. If the primary purpose of making a measurement is to determine a quality of a product, then one should measure that quality directly, not indirectly, right? So here is the advantage in case of direct measurements, because what you are measuring is directly related to the quality. So in this case the chances of error, or the chances of you can say your system failure are very less, right? That's why this whenever possible we always resort to direct measurement, right? So whenever it is possible, direct measurement is always better than the indirect measurement. So direct measurement, however, is not always possible. However, then what we should do? We should resort to the indirect measurement. So in indirect measurement, an empirical relation is generally established between measurement actually made and the results that are desired. So you have to derive some relation. Suppose in the example of that milk pasteurization, there has to be a relation between number of bacteria and the temperature. Higher the temperature, lesser will be the number of bacteria, right? So you have to devise some sort of relation that has to be determined experimentally. That's why it is known as empirical relation. It has to be devised beforehand for any type of indirect measurement. So another thing is, so as you know, there are many factors that result in change in relations in indirect measurement. Suppose in this particular example of this milk pasteurization, so it's not that number of bacteria are only dependent on the temperature. It will depend upon the other factors also, like humidity, right? If there is a higher humidity in the area, then the survival rate of the bacteria will be higher, right? Or just an example, there are other factors also. It might be the case that the time will also play an important role. So for how much time you are maintaining that temperature, that will also, you can say, alter the bacteria count. So you have to list down all the factors, you have to study all the factors, right? so that your empirical relation that you have derived holds good for all the conditions that the system will encounter during its operation. So if there for we can say some reason or the other there is a breakdown in these relations, then it will cause the measurement to become meaningless. So that is the reason why we resort to the direct measurements. If you are having no option, you have to use only indirect measurement, then you have to study all the factors carefully. Elaborate study is required, and then on the basis of elaborate study, you have to devise the empirical relation that holds good for you can say the variety of conditions uh, to which the system can pass through. So this is about the types of instrument. Next we will discuss the instrument and instrumentation. So a number of times these two terms appears to be same, but these two terms are different. So let's see how these two terms are different. So first of all, instrument. An instrument can be defined as a device for determining the value or magnitude of a quantity or a variable. Right? So what is instrument? Instrument is a device for determining the value or magnitude of a quantity or variable. Next is measuring instruments define the instrument's use. So for what purpose that instrument can be used, what are the you can say applications of that instrument, right? So measuring instruments define the instrument's use. Next is these are the means by which the variables and the relations between the variables can be found. So these serves as some means. Next is formal test methods define the use of specific type of instruments for reproducible results. So sometimes you are having a test method. Likewise, you have studied in the chapter on polymer testing and quality control, where we have studied the number of test methods, right, for determining the different physical quantities like thermal conductivity, density, temperature, right? For that, in the standard test methods, the specific type of instruments are mentioned. So you have to use that instruments only for reproducible results. Next is instrumentation. Instrumentation is a collective term for measuring the instruments that are used for indicating, measuring, and recording physical quantities. Right? So what is instrumentation? Instrumentation is a collective term, right, which includes a number of instruments that are used for indicating, measuring, and recording physical quantities. So it is a group of instruments. Next is instrumentation is the basis for control of a process. So in order to control any process in its totality, what you should know, what you should do, you should use a number of instruments, right, that may be used for indicating, measuring, and recording for all the critical parameters. Next, it provides the various indications to the operator for controlling the process. So in some cases, operator records these indications for evaluating the current condition of a process and to take actions if the conditions are not as expected. So that is very important. So it is the you can say the first step towards the automatic process control. So operator in order to maintain the quality, in order to maintain the process variable within specific limits, what is the first thing? First thing, you have to measure it. For measuring, you need instruments, or you can say for effectively controlling, sometimes you need a number of instruments. You may require a recording as well as indicating type of instrument, right? So if the variables are not as expected, or if the variables goes beyond the desired specific limit for control, then what the operator should do? Operator should change some manipulating variable, or should apply some corrective action in order to bring that variable within that limit. Then, because of continuous interactive nature of most of the processes, manual control is not feasible, right? Suppose there are three variables. So one variable is going outside the specified limit, but it is somehow related to the other two variables also. So what you should do? So you have to, while changing the while controlling that particular variable, you have to take care of other two variables also simultaneously. So sometimes the number of variables may be more than 3, 4, 5, 6. So in this case, the control becomes increasingly more and more difficult, and sometimes it is unreliable also. So you can say there are, you can say, number of chances of errors when you apply any control strategy, right? Sometimes what a operator needs to do, suppose for increasing the temperature, he has to open the valve for you can say some jacketed vessel is there for controlling the temperature of the reaction mixture present inside that vessel or reactor. So for some reason or the other, the temperature suddenly falls down, and you have to increase the temperature. It is a clear indication that the temperature of the reactor falls. So what should operator immediately do? The operator should open the valve leading to the heat transfer medium circulation in the jacket of the reactor. But somehow, for some reason or the other, he do exactly opposite to that. Instead of opening the valve, some preoccupied mind, that operator, you can say, close that valve. What should happen? Then the results becomes completely unreliable. So for that you need a automatic process control in which the chances of error are human, you can say, errors are minimized to you can say very low level. With instrumentation, automatic control of such processes can be achieved, right? Here lies the importance of this instrumentation. So you can control that these type of processes automatically. So with instrumentation, automatic control of such processes can be achieved. Instrumentation is used in almost every industrial process and generating system where consistent and reliable operations are required, right? So there you need a instrumentation where you need a consistent and reliable operations. Next, instrumentation provides the means of monitoring, recording and controlling a process to maintain it at desired state. So that is very important. So you are doing lot of things. For doing that lot of things, for monitoring, recording as well as controlling a process to a desired level or desired state. Some narrow, you can say, range is given for controlling the variables, or not only a single variable, there are 7 to 8 variables are there. So all These 7 to 8 variables can be controlled effectively with the use of instrumentation. So here is the, you can say, the difference between instrument and instrumentation that we have just discussed. Now we are going to discuss the importance of instrumentation. Instrumentation provides the basis for automatic control in the industry. So this is the first step. So as we have discussed in the beginning of the chapter, there are two parts. The name of this chapter, name of this subject is process instrumentation and control. So instrumentation is the first step to apply any control strategy. So in this lecture we restrict ourselves to the instrumentation only. That the process control part we will discuss in the next chapter in detail. So in industrial control, a wide number of variables like temperature, flow, level, pressure has to be sensed simultaneously. So in the coming lectures, we are definitely going to study the different types of instruments used for measuring these important variables like temperature, flow, level and pressure. So all of these can be interdependent variables in a single processing, require a complex microprocessor system for total control, right? For that you need some sophisticated controller. So we will discuss the different types of controller also in this particular subject. So a complex microprocessor system is required for the variables which are highly, you can say, interdependent upon each other. So due to more advancement in technology and the efficient measurement techniques, so instruments that we are using today may be obsolete in future. So here is an important point. So the technology is growing at a very fast pace. So instrument we are using right now in the industry may obsolete soon, right? Because of there is rapid advancements in the technology. So you should update yourselves with the latest advancements also, right? So that you can apply the best possible instruments that is available at a, you can say, competitive cost to you as per your requirement. Main objectives of instrumentation in a processing operation of a industrial plant are: number one, safe plant operation. So safety is of great concern, right? So the safety measures can be improved with the help of appropriate type of instruments, right? Suppose in the pressure vessels you can have pressure safety valves. So as soon as the pressure inside that pressure vessels goes beyond a specific limit or specific value, that safety valve opens up to maintain the pressure inside the boiler. It saves the precious lives of the workers working in that high pressure vessels area. Next is high production rate. Definitely you can increase the production rate with the help of instrumentation, right? Next is to maintain a product composition within the specified quality limits. Means for quality control you require a instrumentation. Every time if you are measuring the variable accurately with the help of appropriate type of instruments, then definitely your product quality will be higher. Next is to reduce the production cost. So last but not the least, very important, in order to have a competitive advantage, as we have discussed earlier also, every variable has to be accurately measured, right? It going to reduce the, you can say, first of all it will increase the efficiency of production, right? Then it will minimize the wastage also. All these contribute to contribute towards reduction in the production cost. So these are the topics that we have covered in today's lecture. In the introduction, that is preamble. Next is we have discussed the measurement. Then meaning and purpose of measurement we have discussed. Next we have discussed the different types of measurement like direct and indirect, in which if the meaning and purpose of measurement is same, then it is called a direct measurement. If meaning and purpose of measurement are different, then it is called an indirect measurement. Next, we have discussed the instrument and instrumentation. For a single instrument, single device which is measuring a single variable, it is known as an instrument. Then if the number of instruments used for effectively controlling a process is known as instrumentation. Instrumentation is a term used for a group of instruments that may be used for indicating, recording, measuring. Next, we have discussed the importance of instrumentation. Now let's try some of the questions that what we have discussed today. So the first question is, which of the following terms mainly alters the numerical value associated with the measurement of a physical quantity? So your choices are accuracy of measurement, unit of measurement, speed of response, and fidelity. So this we have discussed in the beginning of the lecture, that which of the following alters the numerical value. So first one is the accuracy of the measurement. It is not going to affect the numerical value. It is, you can say, the static characteristic of an instrument that we will discuss in the subsequent video lectures. Unit of measurement, of course, it is the right answer. If the unit is larger, then the numerical value is smaller. If unit is smaller, then the numerical value associated with the physical quantity is larger. So that is the right answer. Then next two choices, that is speed of response and the fidelity, are again the characteristics. These two are the dynamic characteristics of the instrument that we will study in the coming video lectures. So right answer in this particular case is the unit of measurement. So next question is, which of the following increase the capabilities of plant operator for controlling the process? It increase which of the following? First, air. First choice is air. Second is water. Third is instrument. Next is light. So air and water, these are the utilities which are, you can say, available in any plant. Next is light. This is again a utility available in the plant. So right answer in this case is C, that is an instrument, right, which is going to increase the capability of a plant operator. So right answer is instrument. Next question is, if the meaning of measurement and the purpose of processing operation is same, then the type of measurement is called, your choices are indirect measurement, useful measurement, direct measurement, and none of the above. So first choice, indirect, is not the right answer, because if it is different, then it is called a indirect measurement. Useful measurement is just a term used to describe whether that type of measurement is useful or not. Next is direct measurement. That is the right answer, because it is the definition of the direct measurement. If the meaning of measurement and the purpose of processing operation is same, then it is called a direct measurement. So the right answer is the direct measurement, C. Next question is, the measurement of temperature in a milk pasteurizer is an example of which type of measurement? First is direct measurement, second is indirect measurement, third is superficial measurement, next is none of above. So direct means it is not a direct, it is indirect. You are in the milk pasteurizer, the important thing is what is the purpose? Purpose is to control the bacteria count. So but here you are measuring the temperature. So measurement is of indirect type. Superficial measurement is related to the measurement of surface area. So here it is not a right answer. D is none of them. So the right choice is indirect measurement. B. The right answer is indirect measurement. So next is the collective term for measuring instruments that are used for indicating, measuring and recording physical quantities is control center, instrumentation, automatic process control, transmission. So control center is a central place where the instruments are kept. Not a right answer. Instrumentation, of course, is a right answer. We have discussed in this lecture. Automatic process control is a control strategy. Transmission is for transmitting the signal from one point to another. So right answer is B, that is instrumentation. So that's all for today's lecture. If you are having any questions and doubts, you can raise your queries at my WhatsApp number or at my email. So thank you to all of you for this lecture. Next time we will start with the process instrumentation and control basics.